Welcome back to part 4. This is the energy cost of leg ergometry. So if somebody's on a cycle, or if you've ever been in the lab and seen the Monarch cycle ergometer, this is what we're talking about. So how do you determine energy cost or VO2 of somebody that's on a bike? Well, very similar to our other walking and running formulas, where the gross VO2 or overall VO2 is going to equal the net VO2, which is basically cycling plus resting VO2. The net VO2 is cycling with the resistance and then plus unloaded cycling. So for cycling, you determine rest, which is 3.5 mils per kg per minute, unloaded cycling, which is 3.5 mils per kg per minute, and then the loaded cycling. The loaded cycling is calculated using resistance. So whenever you're doing a cycle ergometer, there's actually a tray or a dial, and then if you add weight to the tray or if you turn the dial, it adds resistance to that wheel, which increases the intensity. If you've ever taken a spinning class, you know what I'm talking about. When you turn that dial, it gets a little bit harder. So if I'm going to do cycle ergometry, the constants for net VO2 are going to be 1.8 times kilogram meters per minute. And I'm going to divide that by kilograms of body weight. So I need to know the resistance or the watts or the kilogram meters. And then I need to know the person's body mass. So once I determine that, the unloaded portion is 3.5. The resting is 3.5. So what you're going to see is instead of plus 3.5 plus 3.5, you're just going to see plus 7 mils per kg per minute. Now, this kilogram meters equals the kilograms of resistance on that flywheel times the revolutions per minute times the distance meters per revolution, which is 6 meters. Typically, the kilogram meters is given, or you might be given watts. Watts is another measure of power. So if you're going to use watts instead of 1.8, it's going to be 10.8. And I'll show you an example of that. So here's an example. What is the oxygen cost of doing 600 kilogram meters per minute on a cycle ergometer for a 50 kilogram person? So VO2 in mils per kg per minute equals 600. This 600 is given, that's kilogram meters per minute. I'm going to multiply it by my constant 1.8 mils of O2 per kilogram meter. Then I'm going to divide by body mass, which this person is only 50 kilograms. Once I calculate all of that, I'm just going to add 7 mils per kg per minute. How did I get 7 mils? It's rest, 3.5 mils per kg per minute, plus unloaded cycling, which is 3.5 mils per kg per minute. So when I multiply 600 times 1.8, I get 1,080 mils per kg per minute. Then I'm going to divide that by the person's body mass, which is 50 kilograms. And then I'm going to add 7 mils per kg per minute. When I take 1,080 and divide it by 50, I get 21.6 mils per kg per minute plus 7 mils per kg per minute. So the VO2 is 28.6 mils per kg per minute. So I can also do the same problem using watts. So if I'm given watts, what is the oxygen cost of riding at 100 watts on a cycle ergometer? 100 watts is the same as 600 kilogram meters. The difference is in the distance of the wheel, which is 6 meters. So it's just a different measure. But 100 watts is equivalent to 600 kilogram meters per minute. So to take the watts, I'm going to take watts times 10.8. So if you're given watts, you're going to multiply by 10.8. If you're given kilogram meters, you're going to multiply by 1.8. So 100 watts times 10.8 mils of O2 per watt. I'm then going to do the same thing and divide by body mass. And then I'm going to add 7 mils per kg per minute. Remember, this is rest plus unloaded cycling. When I go 100 times 10.8, I get 1,080 mils per kg per minute. I divide by 50 kilograms. I add 7 mils per kg per minute. When I divide 1,080 by 50 kilograms, I get 21.6 mils per kg per minute plus 7 mils per kg per minute gives me 28.6 mils per kg per minute. So it's the same thing as my last example because 100 watts and 600 kilogram meters are the same thing. Let me show you that relationship. This is the cycle ergometer that I was telling you about. And on this cycle ergometer, resistance is added with a dial. And as it's dialed in, you can see that this portion, this pendulum will swing and add resistance. Okay, so this is a cycle ergometer. The wheel is 6 meters. So we know that 1 watt equals 1 Newton meters per second. Let me show you what those mean. 1 Newton equals kilograms times 9.8 newtons per kilograms. So if you're given the resistance, this is kilograms of resistance. This is the person's body mass. So if I put 4 kilograms of resistance on this wheel, the 4 kilograms is 39.2 newtons, which is equivalent to 40 newtons. We typically, since you're dealing with significance, the 39.2, the difference in that and 40, it's not significant. So what we do is if we put 4 kilograms of resistance on this flywheel, we just round that up to 40 newtons. So multiplying kilograms of resistance by 10 is universally accepted when you're performing these calculations. So in exercise physiology lab, if you have 3.5 kilograms of resistance, that's just going to be 35 newtons. In our example, we have 4 kilograms of resistance, so that's just going to be 40 newtons. Then, if you take the 40 newtons of resistance that we just had, and you multiply it by the revolutions per minute, so this is how fast you're spinning. We're spinning at 50 revolutions per minute. And then every time this pedal goes around, this wheel goes around. And every time the wheel goes around, it's 6 meters. So how much work are you doing? Work is force times distance. So the force is 40 newtons. The distance is 6 meters. And you're doing it 50 times per minute. And then to convert, we know that there's 1 minute and 60 seconds. So 40 newtons times 300 meters per minute. How did I get that? 50 revolutions per minute times 6 minutes per revolution. Revolutions cancel out. So I have 300 meters per minute. And then I multiply that by 1 meters per 60 seconds. And I get 12,000 Newton meters per minute. And then I'm going to divide by 60 seconds and get 200 Newton meters per second. If the canceling of units and confuses you a little bit, remember that I have a video on how to do that has multiple examples. So if you want to view that and then come back and look at this problem, I think it probably will help you. So 200 Newton meters per second is equivalent to 200. Why 1 watt equals 1 Newton meters per second. So I'm just showing you the relationship between kilogram meters and watts. So the commonalities for stair stepping is you have the horizontal and vertical component plus resting VO2. I'm not going to ask any questions on this, but I wanted you to be aware that the formulas are very similar, and all you do is plug in the different values for with these coefficients, and F being frequency in steps per minute, and height being height in meters. Okay, so we're not going to do any stepping examples, or you're not going to have any questions on that in this course, but you will do it in 340, or if you choose to do a bench step field test, this will come in handy. So use those supplemental videos if you need help. I'm also going to post some different proofs so that you can practice these problems, but along the way, if you need any help, please let me know.